739 daily temperatures. So we are giving an array of integer temperatures represents the daily temperatures. We need to return an array answer such that answers I is the number of days you have to wait after the ith day to get a warmer temperature. Yeah, so let's just check the result. As we can see, for the first one, the index is 0. The next greater element is 74, and the distance from 74 to 73, it is index 1 minus 0, it is 1. And for 74, it is 75, it is still 1. And 75, the next greater element is 76, and the distance is 4. Yeah, and for all others, it's similar like that. So actually, this is our next greater element problem. Yeah. So if we use brute force, basically it's going to be O(n) squared, and n is a really big number. It is 10 to the power of 5. It means it is not possible. So if we are going to calculate the next greater element or next smaller element, normally we're going to use the monotonic stack to solve the problem. Yeah. If we are going to solve the next greater element problem, basically it is a monotonic decreasing stack. Yeah, because if it is increasing, we're gonna pop it out. After pop it out, we're gonna get a result, because basically we're gonna use the index to get the result. Yeah, because we can use the index to get the distance. So if we are going to calculate the next smaller element, normally it is the monotonic increasing stack. Yeah. So it is always dependent on the descriptions. Now for our problem, it is the next greater element because the temperature is higher. What is the closest days? So we're gonna use the monotonic decreasing stack to solve the problem. Yeah, we're gonna prepare a stack as an empty stack. Yeah, so let me just simulate a little bit about the operations of this kind of monotonic stack. Yeah, so we are having an empty stack, and now we are going to put numbers inside of the stack. It is 73. Now we have the next greater element it is 74 because it is greater. So we're gonna pop out this number. So we're gonna pop out 73, but this 73 have an index as 0. Yeah. Now we have a 74, and 74 have an index of 1. So what is the distance from 74 to 73? We can use 1 minus 0, so it is 1. So it means for 73, we're gonna have a record inside our result array. It's gonna be 1. Next, and we're gonna use the 75. Similarly, we're gonna do the same step. So we're gonna pop out 74, and we're gonna put 75 inside. So what is the distance for 74? We have a distance for index 1. It is still 1. Now we have the next number. So as it is smaller, so we put it inside. Smaller, 69. We put it inside the stack. And now we have a 72. Yeah, so what are we gonna do? We're gonna pop out 69, and we have a record of the index for 69. It is 1, and we're gonna pop out 70. Yeah, we're gonna pop out 71, and it's gonna have a distance. It is 2, and then we're gonna pop out 75. So for 75, what is the distance? So this is yeah, there's a we will not pop out 75 because 75 is bigger. Yeah, we just pop out the smaller if it is smaller. Now what is inside of the stack? It is 75, 72. Yeah, it is 75 on 72. Now we want to put 76 inside. Yeah, we have to pop out 72, and we have a record of 72. It is 1, and then we pop out 75. It have a record of 4. Yeah, now what left behind? It is 76, 73. Yeah, so for 76 and 73, we cannot pop out anything. So this means for the index, it's gonna be 0 and 0. Yeah, so this would be the whole operation of the monotonic stack. Yeah, now we just try to solve it. So we're going to use it for in enumerate the temperatures, and we're going to use a while loop to check. So this is the basic structure of monotonic stack. We have to check if the stack exists, and we're going to use this n if it is more than the temperatures of stack -1, it means if it is greater, we're gonna pop it out. So we're gonna use a j as index to record the index of stack. So stack pop out to the index, and we're gonna use a result array to prepare the result. Yeah. So yeah, from here we can still use a variable n. I think n should be a length of the temperatures, and here the result array would be equal to 0 times n. Yeah. So if here we used n, here we had better use another variable just to distinguish that n variable. Yeah. So we're gonna use this temperature t. Yeah. So from here, if we pop it out, so so we're gonna record the index. Yeah. So this I is normally bigger, and this z is just popped out. So we're gonna use this z popped out index, and here gonna be I minus j. Yeah. So after the while loop, we're gonna put it inside. So if there's no stack, the stack is empty, and we're gonna put it inside. Yeah. We're gonna put the index I inside. Yeah. So this is gonna be the operation of the monotonic stack. So if there's something, we're gonna pop it out. Yeah. If the stack is empty, we're gonna put it inside. So if it is not more than, if it is decreasing, we're gonna still append it inside. So after that, we just need to return the result. The result as array is just we define it, yeah, like that. From beginning, it's gonna always be zeros, and then we're gonna update the index and update the distance of the index. Yeah. Now let me check. So this j would be smaller, this I, and here would be this j. I think now it is okay to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and it's pretty fast. Thank you for watching. See you next time.